I left my note in my office, so I just bring a new section, and then we start from section 1.5 here. Okay. So quadratic equation. Before we get to quadratic equation, we need to define a complex number or first imaginary unit. We define that I as the imaginary unit. I will be square root of -1. Because of that, if we square both sides, I square is equal to -1. So I is equal to negative square 1. Okay. So just I is square of -1. The set of all the numbers of the form a plus bi, a is real number, b is real number, is called the set of complex number. Here are some example of complex number. We could have 5 minus 2i, so a real and imaginary, or -3 plus 2i plus 3i. Or we might have just real numbers, 6. That also complex number. A real number is complex number, just as purely imaginary, that also complex number. So complex number may have real and imaginary, or just real, or just imaginary. They all complex numbers. And the complex number a minus bi and a plus bi are conjugate or complex conjugate of each other. So when we multiply them out, a times a, that is a squared, a times minus bi, that minus abi, bi times a bi, and bi times minus bi is negative bi squared. And then we have this I squared is -1, and we have -1 for I squared, and that gives us a squared minus -1, so a squared plus b squared. We'll get back to this in chapter 3, but for now, complex number, square root of negative number, I mean that imaginary. So let's simplify this. If we have a negative inside a square root, that is an imaginary I outside square root and square of b. So if we see a negative, that's going to be I outside the square root. Right. So let's see, how do we evaluate this? Negative square root of -4. Let me copy the problem. Square root of -4. So first thing we'll see is that negative inside square root, and that becomes I outside the square root. And so that negative inside square root is I, and now we have 4. And square root of 4 is 2, except I times 2, and that is 2i. So 2i equivalent to square root of -4. Okay. Now go to square root of -12. First we see a negative inside the square root, so that becomes imaginary, and then square root of 12. Outside square root. Okay, and now how do we simplify 12? Well, in that case I'll ask again, how did we have from here to 2i. Okay, so the square root. So let's just write this out again. If I rewrite negative square root of 4, negative square root of 4 is like negative 1 times 4, right? Negative 1 times 4. And then the negative 1, remember, is I square, right? Negative 1 is I square. And the 4, you can write as 2 square. 2 times 2. Bottom line is you should write like this. Negative 4 is I square, which is I times I. And then 2 times 2. Okay. You can write like that. Now how did that help? Well, the rule of the square root is that square root of a pair of a number or square of anything, you can write that outside square root. We have a square of 2, square of 2. I mean a pair of 2. That common out square root. So for every pair, one number come out. For every pair, one number come out. And there's nothing left inside. And we're left with 2i. Okay, so that's good. Okay. Now, the 12. So what do we do with the 12? The 12 we have to write as a product of things, like in particular, not just any things. I should write prime number. Prime numbers are 2, 3, 5, 7. Now say, what is the common properties of these numbers and why do we call that prime? Well, the definition of a prime number is any number that divide by 1 and itself can only divide by 1 in itself. So prime. So only divisible by 1 and itself. So you see 2 divided by 1 and 2, 3, 1 and 3, 4, well not 4 because 4 divisible by 2, 5, 1 and 5, 6 can divide by 2, can divide by 3, so 6 is not prime, 7 is prime, 8 is not prime because 8 divided by 2 and 4, so no. And the next one will be 11, and that's the list of prime number. Okay, so I prime numbers. And now we can break down the 12 using the prime number. So is 12 divided by any of this? We start with the smallest possible. That is 2. And then 12 divided by 2 is 6. 6 divided by any of this? Okay, 2. 6 divided by 2 is 3. So 12 is 2 times 2 times 3. And now we have a pair of 2. A 2 will come out. And then the 12, the 3 is still inside because just by itself. Just 1 3, so it stay inside. And usually we have that. Now usually we write alphabetical order, number first, and then alphabetical order, and then anything left out like square root of 3. So 2i square root of 3. Okay, so let's take a look at something else. Okay, let's say 24. Okay, what is square root of negative 24? So first that negative is imaginary I. Okay, now 24. Now we will break 24 using the prime numbers. Divide by 2 is 12. Keep divide by the smallest possible, 2, that gives you 6, and then 2 and 3. Okay, so we can write I square root of 2 times 2 times 2, 1, 2, 3, and then 3. And we have a pair of 2, so that 2 come out square root, and the 2 and the 3 here inside. And that gives us 2i square root of 6. Yeah, we just like that. So for every pair of number, we take it out. The negative 1 actually is a pair of I, so that come out square root as well. Okay, so that just, oh, sorry. So by the way, the recording, the question that you speak out will not be in the recording. So if you have any question, please ask. It will not be recorded. Okay. Quadratic equation. Now this is the main thing about this section, is how do we solve quadratic equation. So quadratic equation is the equation that have the highest degree of x squared. The highest degree is x squared. So we really need the x squared to make it a quadratic. So the coefficient cannot be equal to 0. If it is equal to 0, we don't have that x squared as the highest power, and that's not a quadratic. So we have to have the highest power of x squared. Okay. Now, how do we solve for it? In this section, there are 3 different ways to solve for it. By factoring, completing square, and and quadratic formula. After this section, I prefer to just use quadratic formula. Right. So factoring. So factoring, we'll use the zero product principle, meaning using zero product principle. So what is zero product principle? Zero product principle says that if a product is 0, then one of the factor is equal to 0. So it only works if it is 0, hence the name. For example, if I ask you if a times b is equal to 8, then what is a? What is b? Well, a and b could be, a could be 2, b is 4, so 2 times 4 is 8. Or 1 times a is 8. Or negative 1 times negative 8, also 8. So there are a lot of options we can have if it is not 0. But when it is equal to 0, one of them has to be 0. No other way around it. A product is 0, one of them has to be 0. Because if they're not going to be equal to 0. So that is a zero product principle. Product is 0, one of the factor must be 0. So let's just spell it out. Zero product principle, meaning if a product is 0, if product equal to 0, product meaning they multiply each other. If product is equal to 0, then one factor must be 0. At least one factor must be 0. So that is a zero product principle. That's simple. We just need to get 0. Getting 0 is easy, but how to get a product? And to get to a product, what we do is called factoring. So we try to turn this ax squared plus bx plus c into, we turn this into something like, how we use different coefficient, mx plus p plus n times px plus q. That is a product. So if we can turn this into a product, that equal to 0. So this is 0 and that is 0. So the goal is to try to turn this into a product, and that equal to 0. Come later. So how do we do that? So the way to factor this is we using the product and the sum. So the first step is to split the middle term into two numbers, b1x and b2x. So pretty much we split the b1. Let me just reason ax squared plus bx plus c. We will split the second term bx into two terms, b1x and b2x. Okay, let's just write like that. Yeah, so from 3 terms we turn into 4. And how did that help? Well, when we turn into 4 terms, we can factor the first 2 and then the last 2, find the common things between them. Alright, so try to split the middle term into 2. And how do we split them? Well, using this product and sum. A product will be equal to the first times the last, and the sum is the middle number. Keep that in mind. So that's how we do it. Okay. Now let's factor this. So I will write a few steps here in factoring. To factor, first step is we'll find two numbers. Such that, okay, so two number, we say the product, meaning something times something equal to the first times the last. And something add something equal to the middle. So 6 is the first number times the last number. That gives us negative 36, and negative 5. This is the middle number. Okay, so find two numbers when multiplied together equal the first times the last, and the middle number is where they add together. Okay, now how do we find them? Well, just try and error. Okay, get to negative 36. So what times what is negative 36? There are a lot of choices. Okay, 1 times 36 is 36, but one of them needs to be negative. So negative 1, 36, and 1, and negative 36. 2 times 18, negative 2 times 18, and 2 times negative 18. And all of those give us negative 36, but none of them add up to negative 5, meaning that we just have to keep going. Okay, negative 3 and 12, that's still not negative 5. 3 and negative 12, that's still not negative 5. How about negative 4 times 9? That's still not negative 5. But 4 and negative 9. Well, we found it. 4 and negative 9. 4 and negative 9 add up to negative 5. So yeah, we found it. So after we found the two numbers, next we split the middle term. split the middle term like this. Let's write the problem again. 5x squared, sorry, 6x squared minus 5x minus 6. And we split into, let's say, positive 4 and negative 9. Of course, it's an x, so they have to have an x. So 4x minus 9x. It doesn't matter where you write negative 9 and 4 or 4 and negative 9. It doesn't matter. Now we have 6x squared and minus 6. Okay, so we have that. Okay. Now we split. Next, we factor. And factor, there are two different methods. We can use factor by grouping or factor by something else. We'll discuss that later. But now, let's see. We can use either one of these methods. The first one is factor by grouping. By grouping, meaning the first two terms and the last two terms. 6x squared plus 4x minus 9x minus 6. Okay, grouping the first two terms and the last two terms. So how do we do factoring though? Well, we find something in common, and what not in common, we put in the parentheses. Okay. Now, let's see, we have 6x squared and then plus 4x. If we write out like prime factoring that we have earlier, 6 is 2 times 3, x squared is x times x. So 6x squared is 2 times 3 times x. The 4 plus 4 is 2 times 2 times x. So that's 4x. Now, just like that. Then I ask you, what do they have in common? And you say, okay, this has a 2, it has an x, this has a 2, and this has an x. So those are the common. Let's write the common term out, 2x. The term that have in common. Okay, so what not in common? Well, the 3 and x are not in common, and the 2, the plus 2 are not in common. So that's how we factor. Find something common or outside, and something not, stay inside. Right. So for that, we will have 2x and then 3x plus 2. Okay, now the negative 9x and minus 6. Negative 9, 9 is 3 times 3 and then times x. 6 is 2 times 3. And what do they have in common? Negative and a 2, sorry, a negative and a 3, right? And like negative 3. So you write the common term outside. So what's left inside? Well, you see the 3x, right? You take the negative, you take the 3 out. Thing left with only is 2 and positive 2. So we have to have something there, positive 2. So that's the sketch work, the scratch work to get to that. So negative 3x, and then we have 3x plus 2. Okay. Now if you do correctly, if everything works out perfectly, we should have a common factor. Again, 3x plus 2, 3x plus 2. So what do we do with them? Well, we write that in front. And we left with 2x minus, sorry, there's no x here. There's no x in common. There's no x in common, just a negative 3. And then we have 2x minus 3 left. So that is factor by grouping. Okay. You certainly can do that. Alternatively, we can use the box method. So instead of doing this, we can use the box method. So in the factoring step, you can just use the box method. So we draw a box, a 2 by 2. Okay, so you have 6x squared and minus 6. Yeah, the first and the 6. And we still do all of this to get 4 and negative 9. And in fact, we're going to put 4x and negative 9x here. And then the factoring is still the same thing. What do these two have in common? Okay, the 6 you write 2 times 3 times x times x. The 4x 2 times 2 times x. The common of them is 2x. So these two, the common is 2x. Now, these two, negative 3 times x. Negative 3 times x. Negative 3 times 2. So the common is negative 3. By the way, the signs always go with the one on the left or on the top. Again, if there's a negative sign on the left or on the top, it will be negative. Correct. Now, 6x squared, 2 times 3 times x times x, negative 9x, negative 3 times x, and they will have a 3x in common. And this, they will have a positive 2 in common. And finally, we have 2x plus 2, and then 2x minus 3. So that is the box method. Nice thing about the box method, we just need to find the common terms. We don't need to know what's left. Okay. Now let's solve quadratic equation by factoring. Again, factoring meaning we use the zero product principle. Right. So we need to have a zero and we need to have a product. And to get zero, well, that's easy. Just get 0 on one side. So 0 meaning that get 0 on one side of the equation. And to get the product, that by factoring. So we do two things to get a 0 and to get the product. First, to get 0, well, that's easy. I move the 4, subtract 4 on both sides. So 2x squared plus 7x minus 4 equal to 0. So now we have a 0. Thing left to find is a product, and that by factoring. So first, I'll do this 3 steps here. The first, find the two numbers. Find two numbers where multiply together equal the first times the last. Alright, fine. That's fine. Like I said, this video is being recorded. I will post it later tonight. And I will not take attendance today because this is special circumstances. I should not be counted against anybody. So 2 times -4 is -8. I just want to make sure that we done something this week because we don't have class on Monday already. Right. So find two numbers multiply together equal the first times the last. Not -8. And then when they add together will be equal to the middle number 7, right? So find them -8, right? So to get to -8 is 1 times 8. Well, one of them is negative, and around the first one it is 7 already. So yes, these two put together is equal to 7. Yeah, so we're done. We found the two numbers, -1 and 8. And the next step is we split uh, 2x squared plus 7x minus 4. We split the middle. By the way, this is the equation, so just keep the 0 on the other side. So we split. That gives us -1. That should be an x. And then 8, -1 and 8. So -1x and ax. There will be 2x squared in front and minus 4 on the back. Okay. So we split. And next, after we split, we can factor. And factor, I'll just use the box method here. Again, the 2x2 box. Uh, 2x squared minus 4. And now we have, okay, we can just put -1x ax or -1x ax, doesn't matter. Just put 1 in this and the other on the other corner. And put negative here. Doesn't matter where you put them. You can flip-flop those two. Right. Now, what do they have in common? The first two terms look like there's an x, and this is only an x. Again, this time we go with the one on the left and the one on the top. Okay. Now, ax minus 4. 2 times 2 times 2 times x minus 2 times 2. Look like there's just a 2. And the sign will go with the one on the left and on the top is positive. So positive. Now, this 2 times x times x. 2 times 2 times 2 times x. There will be 2x in common. And this, nothing in common but the negative. Always go with the sign on the top and the left. So just have that. And so the factor will be 2x minus 1 and x plus 2. So this will be 4, right? Yeah, 4 and 8. Let's be 4 in common. So x plus 4. And equal to 0. And the rest is easy. We just need to solve for it. We solve this, and that is the zero product principle. A product is equal to 0, so one of the factor must be 0. So we say 2x minus 1 is 0, or x plus 4 is 0. And now we just solve for x. That should be easy. There's 1 on both sides, and that is 2x equal to 1. And then we divide by 2 on both sides. Is 1/2. And now this is easy. We just minus 4 on both sides. So x equal to minus 4. And 1/2 and minus 4 can put on. The solution is -4 and 1/2. So usually we can write the solution in a curly bracket. We have 1/2 and -4. So that's the solution. Okay, once again, factoring method need to have 0 on one side. And then in that case, find the two numbers to split the middle terms, the box method, and then zero factor principle. Right, so we have that. Oh, I'm sorry, which one? This one? This one? This one? Oh, this one. Oh, yeah, you will do either one of these two. I prefer to use the box method. If you use the box method, oh yes, you can do this way too. You want me to do that? So okay, so this 2 times x minus 1 times x plus 8, 2 times 2 times 2 times x minus 2 times 2. Okay, we spell out the whole product, right? So x squared, x times x, 8 is 2 times 2 times 2, like that. Now, grouping the first two, and maybe I just write directly here in the note. Sorry, 2 times x times x times, okay, minus 1 times x plus 8 is 2 times 2 times 2, x 4, 2 times 2, right? Okay, we spell out the product. Now what do they have in common? Let's group the first two. Okay. Yeah, the first two terms look like there's only one x in common. So I pull it out. What's left then? We have a 2 and an x. And then minus 1. Okay. Now what do these two have in common? See, there's a 2 and a 2, a 2 and a 2. That is a 4, positive 4, right? And then it will be 2x minus, there's nothing, we have to write times 1 if there's nothing. Okay. And now we have a common factor, 2x minus 1, 2x minus 1, factor it out. We have 2x minus 1 as a common, and then x plus 4. Okay, so either way, you can use this method by grouping or use the box method. We get the same thing as a factor. Okay. Next we continue on the next one. Okay. By the way, when we try to do the factoring, especially using the box method, it is essential that we have to simplify the problem. So, if the problem like this, we say there's a 2 is even, 14 is even, and 20 is even. So all of them are even, all of them can be divided by 2. So we should do that first. So let me write a little note here. Note, if we factor using the box method, when factor using the box method, need to reduce the problem. Simplify or to reduce the coefficient. Otherwise will not work. Besides, actually, not that we reduce the problem, reduce coefficient, so the box method will work. Not only that, but also turn the problem to a lot simpler. So let's say we just divide everything by 2. And then we say, why do we divide by 2? And my answer to that is we can, because all of them are even. We can divide by 2. 2 divided by 2 is just x squared minus 7x plus 10. You see, not only we have to do it, it's a very nice thing to do. Also, the problem turned to something easier to do. Okay, and then we factor the step. Okay, find the two numbers, split, factor, and then solve. First step, find the numbers. Okay, something times something equal first times the last. Something plus something equal to the middle, -7. Okay, now try and error. How to get to 10. Okay, 1 and 10, no. -1, -10, still no. 2 and 5, no. But -2 and -5 will work. So -2 and -5, that's where we split. And now we split. So we split. X squared minus 7x plus 10 equal to 0. We split that using -2 and -5. Of course, we need an x there too. Okay. So find the two numbers who split. And now the step is factor. Let's of course you can use the box method. This time let's use by grouping. Like I said, either using the box or by grouping. might look silly, but I just want to write x squared is x times x. 7 times x. 10 is, okay, what's 10? It's not going to be 1 times 10, because we're going to write 2 times 5. Remember all the prime numbers we have earlier. Yeah, use those numbers, 2 and 5 in this case. Okay, sorry, we split the middle term, right? I forgot that. Let's do that again. Sorry. Negative 2x, negative 5x. Sorry. So negative 2 times x, negative 5 times x. Yeah. So we spell out the product like that. Now, x times x, there's an x in common. Pull it out. And what's left? We see there's an x, there's a minus 2. And for this 2, there's a 5, and there's a 5. However, the sign always go with the first term. So we will pull out actually negative 5. And then there's x. Notice that because we pull out the minus, a plus sign here, plus 2 times 5 you can write as negative 2 and negative 2 times 5, right? You can pull out a negative 2 and you're left with, you pull out a negative, sorry, a plus 2 you can write as negative 1 times negative 2 times 5. Yeah, so that is the 10 plus 10 like this. So pull out the 5, you're left with an x. Yes, instead of plus 2, because of this minus, it have to be opposite. Besides, we have to have the same factor here. Again, when we factor, always the sign go with the first number. If it happen to be negative, we have to change the other sign, because when you multiply it out, it gives back 10. Okay, so with that, we have x minus 2, and x minus 2 is a common factor. And what's left is x and a minus 5. And the last step is solving using zero product principle. So we have x minus 2 and x minus 5 equal to 0. Now, a product is 0, so each one, at least one of them is 0. And that's easy. Plus 2 on both sides, and plus 5 on both sides. So we have x equal to 2, x equal to 5. And we'll write the solution as 2, 5 in the curly bracket. On my MATLAB, the solution they want to put in between the curly bracket, like that. Of course, you can also use the box method to factor this as well. Okay. Next, we have this one. Still the same way. Find the two numbers to split. One we split. The reason that there are 3 terms, right? So first term, the second term, and the third. We have to split the middle term. So we have the first 2 and the last 2. If we don't split, we cannot group. So find 2 numbers. I'm going to take something times something equal to first times the last. and then add up to the middle number. Okay, so the product of -5. So we have 1 times 5, sorry, this negative, so one of them has to be negative. So -1 and 5, or 1 and -5. But neither of them add up to 3. Okay, and that's all possibility we have. Remember, we cannot have 2 times -2.5. We only use whole numbers. We only use integers here. So 2 and 2.5 doesn't work. So in that case, what we can only say is we cannot factor. And if we cannot factor, doesn't mean that we cannot solve it. There will be a solution. There's always a solution. But factoring is not going to work. Okay, so pretty much just that. Now, because some method doesn't work, I mean, factoring doesn't work here, there must be a different way. And there are 2 different ways that works for all the problem. One of them is this, completing square. So to get to a completing square, worry about that later, but worry about the square. My question is, let's look at something fairly simple. If you have a square is equal to 9, then you say, what square is equal to 9? Then you say, oh, obviously 3 times 3 is equal to 9. So how about a equal to 3? Well, that's correct, but that's not all of it. -3 times -3 also 9. Because both of them square is equal to 9. -3 times -3 equal to 9. Just as 3 times 3 equal to 9. So a square equal to 9. To get rid of the 2, to get rid of that, we will use plus or minus 3. In particular, 9 is 3 times 3, so plus or minus 3. And that's a equal to plus or minus 3. So to get rid of the square root, to get rid of the square, we use plus or minus square root. Let me write this. Plus or minus square root. There are 2 solutions, positive and negative. Plus or minus square root, will undo a square. Okay. Now, we know we can get rid of a square, but first we need to have a square in the first place, so we can get rid of that. If we have the square, get rid of that, plus or minus square root. Okay, so that's easy. But how do we get to the square? From a quadratic like this, how do we turn it into a square? Okay, that process is completing square. So let's see what a square will look like first. X plus b square. Well, that is x plus b times x plus b. A square is multiplied by itself. Now I will multiply x times x, x times b, b times x, b times b. X squared plus bx plus bx plus b squared. Right, we're not factor by grouping. Actually, factor by grouping give us this. We're not doing that. Bx plus bx, that's 2bx. Okay, 2bx. Now, so that's what a square will look like. We know x squared plus 2bx plus b squared is equal to x plus b. So when we have this, we have the square. So what's so special about this? The special part is, if you look at the middle coefficient, the plus 2b, if you take half of that, that's a positive b, right? And then when we square, we'll have the third term. So the middle coefficient, half of that, and then square. When you see that relation, that will make it a square. In particular, this will be equal to a square where one of them is plus b, and we just put an x to it. There. So that is called complete square. We try to get into this, and that is a square. Right, let's see how that works. So now let's try to see. Remember, we need to get a square, and the square will have 3 terms, but the third term has to have some special characteristic. In particular, the question here asks, add a number and complete that square. So we're going to need to add something here. So the result will be a square. Right. I'll do this in 2 different ways, just like most of the things. If we can do 2 different ways, I will. Okay, try to add something to it to make a square. Now, what did we do on the previous page? Oh, half of the coefficient. Half of that is plus 4. And then we will square it. 4 times 4, 16. So we need to add 16, and the result won't be a square. In particular, we have x square plus ax. If we plus 16 to it, we will have a square, where inside the square we have the plus 4. Actually, that go here inside square, and then will be in front of that an x. Okay, so find the third number, add it to that, and that makes a square. Okay, so that's one way to do that. Another way to do that is a little bit geometry reasoning. This will be a lot easier to visualize. Right, first, imagine this. If we have a square or rectangle, let's say rectangle, 2 feet by 3 feet, what will be the area? I will say, okay, the area of rectangle is length times width. So the area is 6, right? That's simple, length times width. Okay, keep that in mind. Now we have x squared plus ax. So by the way, that is a complete problem. Now let's do it differently. Alternatively. Okay. We have x squared plus ax. Now, x squared is a square of sine x by x, right? Yeah, x times x give us the area of x squared. Now, so x times x, and the ax, you can write this as, okay, let this side be x, the other side be 8. Yeah, so x by 8, we have ax. Is that rectangle, right? So x squared, x by x, ax is that rectangle. So what I do now is I break this rectangle in half. Therefore, the 8 is going to be 4 and 4. So this area here is 4x. This area here is 4x. 4 by x, 4 by x. We stack that next to this. Okay, I have an email. So break down 4x and 4x. Right, the 4x. So because we have 4x. By the way, if this is x, that is x, then the remaining side has to be 4, right? So this is x by 4 or 4x. This is x by 4 or 4x. So x times 4, that's 4x. Right? And now what do we need to complete the square? Well, missing is this. Now we have a complete square, do we? And this square, the area will be what? 4 by 4. So 4 times 4 is equal to 16. And that's why we add 16, right? And to recap, this x squared plus ax, we plus 16 to it to make a complete square. And that will be, now the big rectangle, our big square will be x plus 4 and x plus 4 by x plus 4, therefore x plus 4 square. You see, there are two different ways to do this. This will be half of the middle term in square. So that kind of, well, we have to memorize things. I prefer using the geometry here because that makes sense. When we add something to it, we make a big square, and that will be x plus 4. Okay. The only thing that I don't really like doing this is sometimes when it's negative, and when it's negative, it's geometry, we really don't have a negative area. But the principle still remains the same. Even though the negative doesn't really make the area. Okay, x squared minus 7x. We have x squared is the square of x by x. The order is 7x. 7, if you cut in half, that will be negative 3.5 and negative 3.5. Right, half of negative 7. If you have that, but bear with me, it's wrong to write the area is negative 7 by x. Geometry, the principle is wrong, but we just that, let's say that side is negative 7 times x. Okay. And then cut in half. Negative 3.5 x. Negative 3.5 x. Okay, the negative 7 we break into 2 and to make an L shape. So in that case, we have this side x already. This side has to be negative 3.5 and that side has to be negative 3.5. Now we need to make it a complete square. So, and negative 3.5 by negative 3.5. Where's my, okay. Negative 3.5 square times itself is 49/4. You can use fraction, but I will just use decimal here, 12.25. Okay, so that's what we need to add the new area of 12.25. So now we write x squared minus 7x. We need to add negative times negative, so this is still positive, 12.25. the result will be x minus 3.5 times x minus 3.5 square. So that's what we have. Okay, so we make a square, right? So on the previous page, if we have a square, how do we get rid of that? Okay, if we turn the page, to get rid of the square, we use plus or minus and square root. Okay, keep that in mind. Okay. Now, how do we actually solve the equation? By factoring. I'm sorry, by completing square. So first, complete square. Remember, we only need 2 terms here. So we really don't need the 5. So move that to the other side. Complete square, we need 2 terms, and we need 2 terms, and then we'll determine what will be added. So that will be a square. The negative 5 or the 5 doesn't really do anything with the problem. So move that to the other side. We will determine what will be added later. Okay, now we need to add some things here. Okay, now but this time, whatever we add on this side, we have to add on the other side. This time we do have the equation. We not just have 2 terms, we can just add to it. This time, if we have equation, we add on both sides. We'll add something on both sides, and we determine that something to be added. Now, determine what will be added here. So x squared, okay, x by x. For x, cut in half, 2x and 2x. Since this is x, this must be 2, in particular, plus 2. And since this is x, this must be 2. And to make a square, it's going to be 2 by 2. 2 by 2 is going to be equal to 4. So we need to add 4 to make it a complete square. 4. So let's add 4 on both sides. When add 4 on both sides, these 3 terms is going to be a square. We know that's going to be a square. The other side, negative 5 plus 4, that's negative 1. In particular, the square here is what? We see x plus 2 by x plus 2. Okay, so we have a square, and what did we say? What do we need to do to get rid of the square? Well, plus or minus square root. So get rid of the 2, plus or minus square root. We get rid of the square, right? Okay. We have rid of the square, we have x plus 2 plus or minus square root of negative 1. And then we say, oh, okay, square root of negative 1. At the beginning of the section, that is I. So x plus 2 equal to I plus or minus I. And just minus 2 on both sides. We have the solution is x equal to negative 2 plus or minus I. And that negative 2 plus I, negative 2, negative I. Yeah, on my MATLAB you can just type negative 2 plus or minus I, or you spell it out, negative 2 plus I, negative 2 minus I. 2 solutions. Okay. Now to this one, we do the same thing. Complete square, we only need 2 terms. The third term to be determined. So don't move the 10, and so we have x squared minus 7x equal to minus 10, and we'll determine what to be added. Okay, and actually we did this. We determined that we're going to add 12.25, and this square will be this. So I'm not going to do that again. This is going to be 12.25. And that gives us a square of x minus 3.5. And then that gives us 2.25. And finally, to get rid of the 2, undo that we have plus or minus square root 2.25. And we get rid of the square by plus or minus square root. So we remain have x minus 3.5. And what is square root of that? Square root of 2.25 is 3 over 2 or 1.5. Okay, and plus 3.5 on both sides. So we have x equal to 3.5 plus or minus 1.5. And that gives us two possibilities. 3.5 plus 1.5. That is 5. Or 3.5 minus 1.5. That is 2. Now if we compare this with the problem we did earlier. Okay. That problem. Solution is 2 and 5. So this time, indeed we have 2 and 5. Okay. So that is equation by completeness square. There's one more method is using quadratic formula. I think I'll start that on Monday. At least we get something done this week. Once again, thank you for being here and have a good evening. See you on Monday, hopefully.